Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Go with it. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel and what you do with Rachel and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor out 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded. Like tight bond. Original wood glue. It has a tight bond. Like me and Levi.
What's up? Hey, XDMR Hayden. Hayden, we'll go with Hayden.
XDMR Hayden. Hayden. That's how you say it. How's it going? Mojo.
Mojo. Hello, Mojo.
It's been a solid
It's
minute.
been significantly longer than a minute.
How are you doing, Moj?
Moj word?
Moj word. Hey, you did it before me.
I did.
I was thinking about it.
Yeah. You have a little chocolate on the corner of your mouth.
That's impossible.
Not to be confused with the corner of my mouth.
This one?
Which has no chocolate.
Oh, good.
You finish school tomorrow.
Oh my god.
Very exciting.
Yeah.
So you're done with finals and everything?
Yeah. Now, Mojo, you are finishing junior year, is that right?
Do you need help prepping for summer?
Summer? Yeah, summer's gonna be really tough this year.
Really tough.
Yeah, very good. What are you
Tough
doing this
summer.
summer? You going to camp? You gonna go? You get a little job? WDYM. What do you mean? Oh, yeah. I'm very good at figuring out acronyms.
You're so good at it.
Yeah. Did you know
Yeah,
that? That was.
yes.
Oh, really? Have you seen that before?
I'm an adult.
I'm a camp counselor.
Matthew, hey.
Wait. So I was right.
What kind of camp are we talking?
Hold on. Pretty exciting, right?
You didn't guess that.
Yes, I did. I said
you
you
didn't.
going. My camo name is Mojo. Your camp name is Mojo. Oh, that makes sense. That's why you're Mojo. Mojo 1, 2, 3.
Right.
Yeah. Yeah. Is this sleepaway camp? How old are your kids? I've been a camp counselor before. My kids were 14 and 15, and it was 5 to 12.
Nice.
Do you get a whole group of them that's like that range, or like just
That's a big
you don't
range.
know what group you're gonna have yet? 9 to 5, 5 days. Got it. Okay. All right, that's a job right there.
That is such a job.
Is this like a sports camp, or is this just like a camp with arts and crafts? Is this like a
Jewish camp?
like a Jewish camp or like a
Space,
theater camp?
Space camp.
I went to space camp.
School
4
camp.
groups and 2 counselors per group. Got
Nice.
it. Got it. Very exciting. Outdoor rec camp. : Oh.
Yes.
I went to space camp too. Wait, Huntsville, Alabama? Did you really, Mojo? Tell me more, because I went there when I was young. I went to space camp.
Where do you get Huntsville, Alabama?
That's where space camp is.
There's only one?
There used to be 2. There was one in Florida, but they closed it.
Oh, there's like one big space camp.
Yeah.
I thought there would be multiple space camps.
There used to be 2, but there's 1 now. Yes.
What about for second space?
You got the actual jumpsuit. I remember those kids. Oh, gosh. Now, Mojo, did you ever do any of the aviation challenge stuff? Because I ended up going there for my second year, and I did full on that stuff. Because those simulators they had there were just like the bomb. Oh, man.
Hey, Matthew, do you have any questions?
Mojo, what about, do you go on the G-Force? Got it, okay. Who were you in the mission? Do you go on the G-Force? Do you go on the space shot? And what did you play in the mission? Yeah, this is so exciting for me, Levi. I don't know if you want
never
to
talked to me about going to space camp.
You never asked me about it. You went to, yeah, exactly. We were just asking our counselor to take us to G-Force and Space Shot all the time.
No questions, Matthew. Are you done? Are you prepped? Prepped?
Man, what else?
Prep.
Mojo, how old were you when you went? Were you old enough to do like the scuba diving thing where they have you like in the lunar rover? Isn't there an SAT soon? Yes, there is.
Yes, there is.
There is June 1st.
Yep.
Now I was like 9. Yeah, I probably was too. Did you get any of that astronaut ice cream? Because that stuff was good. I got a lot of that at the gift store.
Is that ice cream?
It's like freeze dried.
Astronauts?
Yes, yeah, it's dried astronaut organs.
It's just pureed astronaut.
Yes,
body.
exactly.
Nice.
Yeah. Oh, that's I still find that from time to time. I know. Is that good? It's so gas. Is that what kids are saying now?
Yes, everybody says that now.
Okay. Yes. Yeah, it's very much gas. Yes. Wait, what position? You're mission specialist. Sorry, you said that. Okay. Does that mean you were actually on the shuttle? I think that means you're on the shuttle. That you were a mission specialist.
Let me get my markers.
Because I was commander. The first year, I think I was. Did I do it twice? Yeah, I think I did. I did all the experiments. Yes. Did they have you do like a rubber ball experiment or like a plant experiment? I remember doing a rubber ball experiment as the commander. Yep. Look at that. They're still trying to figure out the same stuff. They haven't figured it out yet. You'd think at this point they'd know what happens to a rubber ball in space. Like elephant toothpaste. Oh, they brought an elephant up there. How do you clean its teeth? That's a new one. I'm having a great time.
I know that.
This is really exciting for
I don't
me.
think I'm needed because Matthew has no questions and I haven't been to space camp.
Yes, that's
I'm
true.
gonna go sit down.
That's fine.
Yeah.
Mojo, here's a fun one. So when I was in college, I did a couple of stand-up, like open mics at the coffee shop on campus. And one of the times I was talking about space camp. Oh, they just did limits in class. I was talking about space camp and like some of the ridiculous stuff that happened there. And then a girl in like the very, very small audience of people who just happen to be at the coffee shop when this happens, she comes up to me afterwards. She's like, I think we were in the same space camp group. And sure enough, we were. She was the pilot and I was the commander. And we were both very young, but like, it's incredible that yeah, exactly. It's insane. Like all of the things that had to happen for her to like be at that shop when I was, doing that. Like, yeah, it was crazy. So we found the old picture and she and I are both incredibly young, awkward, and chubby looking. It was very, very weird that happened. But I think it's because we called our counselor Dad just to make him feel uncomfortable. And she remembered that we called him Dad. And that was like the indicator that she remembered. Anyway, all right, Mojo, you did limits. It's like a sleepaway camp all about space. Yeah, yeah. Mojo, do they put you in the like concentric ring thing where you do a lot of this stuff? I'm sure they did. Did you do the centrifuge at an aviation challenge? Good. You use centrifuge at aviation challenge? Okay. You love that. Yes. This is very exciting. That thing was cool. Yeah, because you start feeling like you're falling. When it slows down, that's really when it screws with you. Yeah. Oh man, this is bringing me back. Space camp, and you got the optional blue jumpsuit. Did you actually wear it throughout camp, or did you just take it home and like have it as a reminder, as a souvenir? You were to school. Oh my god. Oh jeez. Was that just to like have kids ask you about space camp? I remember kids like they wore that thing like every day of space camp. It was like, yeah, that's awesome. Did you stay in the habitat with the big tubes? Because there was like that main habitat, and then there. Yep, very good. Yes, as you should have with the cool windows. Yes, those circular windows in front of the shuttle. Was it a massive building? As I'm thinking about where the shuttle was. Yes. Never mind. I knew that. Yes, exactly. I think, yeah, I know what you're talking about. There's that massive shuttle that you walk underneath to get to, like, the cafeteria and stuff. Yes. Yeah. Oh, man. Us Space Camp alumni, we got to stick together, man. It's, you know, what's happened to us is not good. We got to stick together and fight the good fight. Because we're dropping like flies. You have soda in the morning for breakfast. Yeah. That's what you like the most. That's very funny. I remember the food there. Yeah, I remember a lot of those small ice creams. You can have as many of them as you want. It's like the little styrofoam cup. Yes, soda in the morning is not a good camp policy for many reasons. But they let you have that with the wooden spoon. Yep, with the wooden spoon. Yeah, do they still have that? There's that large dome theater that you watch like a movie about space narrated by Tom Hanks, which I think is still the industry standard. I'm not sure if they're still showing that, but this sounds like a bunch of years ago for you. So it's still later than when I went, but I'm guessing that. Yeah, I mean, what are you? You just finished junior year, so you're probably like 17. So I'm pretty much 10 years older than you, but it was still a really cool movie. We should, yeah, okay. Well, you can keep bringing up memories. We should probably start somewhat soon. Limits don't really show up on the ACT, SAT, so yeah, you gotta go. Yeah, I got to go. Oh, wait, right now you gotta go? Oh, okay, you're just saying hi. Well, I'm glad you had things to do. Yes, it was. It was very good. I'm just filled with fun memories of space camp. A lot of people don't even think it's real. All right, he says bye, by the way.
Bye, Mojo.
Levi says goodbye as well, and Levi says, I wish I'd gone to space camp. He's off camera, so he's just floating in the black void. So it's basically space. We're in space. Very exciting. Hey, Storm's here. Oh, man, this is going to be great. Everybody's here.
Storm.
We're talking logarithms today, big time, unless people have questions.
Storm, do you have questions?
Levi and I just decide what to talk about, but if people actually have questions, we can completely readjust and answer your questions, or there are specific concepts that you want us to talk about. Not yet. Not yet. Capital yet. Very forceful yet. Very forceful. That's good. It's like a very firm handshake. It lets someone know that you're confident. You know what you want. You know how to get it. You walk around the world knowing what you want. It's a good thing. All right, then in that case, we're going to talk logs. We're going to talk logs. So everybody knows, even if you haven't learned math yet, that 5 squared is equal to 25. That is an exponential relationship between 5, 25, and 2. 2 is the exponent you need to raise 5 to become 25, okay? There's another way to express this with a logarithm. Logarithms are just exponents put into a different order, okay? It's just like, 10 plus 3 is 13, and 13 minus 3 is 10. It's the same relationship, you're just expressing it from a different angle, pretty much, okay? Here's what the log of this would be. You would say log base 5 of 25 is equal to 2, okay? It can take a little while to understand the order. A lot of kids have trouble remembering which number goes where, because sometimes you'll need to put exponent relationships into log form. Other times you need to take a log form and convert it back into an exponential relationship. So here's what you can think of this as. Number 1, log is asking the question, what number do you need to raise this number to become that number? What power, what exponent do you need to turn the small number into the big number? In this case, we need 2. That's the number we need. Okay, that's one way to think about it. Next way to think about it that I learned from Levi.
Why not 3, my God?
Very good. Is the Levi Spiral. The Levi Spiral says that if you take this...
Not to be confused with the Fibonacci spiral.
Of course not. You take this to this power, it will give you this. All right, so you make this fun little spiral. 5 to the second power is equal to 25. All right, there is that. There is that. The next thing that you can think about this as, because we are just chock full of chalk, is, here we go, my. That's right, Storm, your. The last thing you can think about is if you're going to express exponents as logarithms, these two numbers just switch places. Your algebra teacher did the spiral thing, exactly, yeah. Your algebra teacher was probably a student of Levi's back in the day, because Levi was the one that created that. You switch these two, and then you just write log in front of the whole thing. So now you got log 5, but instead of having the 2 there, you have 25. This doesn't mean it's 5 to the 25th power, all right? But it looks similar to if you just switch these things, okay? 5 to the 25, log base 5 to 25 is equal to 2. So the exponent now goes to the other side, and it's the one that is alone. Logarithms rip exponents away and cast them out to be alone. That's what a logarithm does, all right? The thing that's alone on the other side was originally the exponent, all right? Very exciting. This is very exciting. We're all enjoying this. Everyone's having a good time, and we're going to keep moving. So in general, if you've got a to the b power is equal to c, you want to rewrite this as a log. B and c are going to switch places. You're going to write log in front of all of it. So the very first thing you're going to write is a. In both situations, a is the first thing. That's not going to change. But now, instead of writing b, we're going to write c right here, and that is going to give us b. All right? Extremely exciting. Extremely exciting. Let's do a couple of log practice problems, and then we're going to talk about some properties. Our natural logs on the ACT. Yes, you have to know what natural logs are. Okay? So that's a good question. Here is what the deal is with what you see in your calculator as log. If you ever see something like this, log 10. No, not 10. We're just going to say, I'll make it a log 73.
Why not 3, my lord?
Why not?
Why not, my lord?
I don't know. I don't know, my lord.
Yes, my lord.
You don't see a base here. You just see log 73. It's like, wait, what is this asking? What taken to a power gives us 73? Invisibly, it is base 10. All right? If you do not see a number there, then it means base 10. You know, it's just like if you see, square root of 36. There's no number here, but it's implied that you're taking the square root. If you see a number there, then it's different. Now we're taking the cube root. But there's no number there. The convention is that means you were taking it, the square root. Same with this. If you do not see a base, that means it is base 10. So what I do is I always write in 10 just to reorient myself about what's going on. All right? So that's what log is. On your calculator either does two things for you. If you press the log button, it either gives you an option for what you put as the base, and it gives you an option for what you put as the big number. Levi, is there a name for this big number?
Yes.
The base and the...
I think it's the...
Is it Alfred?
No.
Oh.
It's 3, my lord.
It's 3. It's always
Yes.
3. No. Okay. If your calculator does that, that's great. And you just, plug in the numbers where they go. Sometimes calculators do not give you that. They just give you log of something.
I think it's of. No.
They give you log of something. So it's like, wait, how do I put the base in? Here's how you do it.
Also,
What?
Matthew, we got your question. We'll do next. Because you say log base 10 of 73.
Right.
So this is base, and this is of.
Right. Has anyone ever told you that
Is this going to make me feel good?
Yes.
Okay.
Has anyone ever told you that you have a very, how do you say it, intense gaze?
Yes.
Okay, good. Now get out of here. So if you want to...
Why'd you bring that up?
If your calculator... Sorry.
It's okay.
You've been told that by multiple people, though.
Yeah, sure.
Right? You don't have the ability to put in a base here, so I thought Levi had glasses. I thought Levi had glasses, too.
I still have them, they're just not on my face.
So here's something. Log base 6 is 70. This is not going to give you a nice number. You'd have to put this in your calculator. Here's what you do if you have this option on your calculator, where you can only take log of something, no base. You put in log of the big number, log of 70. You divide it by log of the small number, log of 6. All right? According to log properties, this is equivalent to log base 6 of 70. That is how you put logs into your calculator if your calculator does not give you this option. Good. Very good. Okay. So, Levi,
Yes.
should we do Ring Matthew's question and then keep going with logs?
Of course.
Very good. All right, I'll erase this so far.
Yeah, you can, yeah.
Yeah, I can and I will.
Hey, can you erase this?
Oh, I don't know what that means.
That doesn't make any sense. Wait, why is this off? What?
What did you do?
What did you mean? Oh, there we go. Bum, bum, bum. Bum, 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 bum.
Rocking and rolling and something rocking.
Is that what it is?
Something rolling. It's from a Tenacious D movie. Pick a Destiny. Can't you see he's the man? Ace Chess! Good evening, how are you? We are well, Ace Chess. And about you, how are you?
Okay. Hui. Hui.
Gotta let it dry, man. You gotta let it dry.
That's how you kiss ghosts, by the way.
You just
Gave mouth to mouth
you
to a
just
bunch of
blow on 'em?
ghosts. Yeah.
Oh. Sultry.
Very, very sultry.
You want to read this one?
Yeah. Okay, so you got this inequality up here, and you're told that m is a positive constant. Okay, so that means it's not a variable, so that's good to know. What is the possible range of values of this new expression? Is the word I wanted. Okay, so
Ace Chess finished with Module 3.
dude, it's modules 3.
Dude, Modules 3 was way better than Modules 2.
Yes.
The production value is getting higher and higher with each module.
I was thinking it reminds me of My Chick Bad by Ludacris.
Is that a song?
Yeah.
My Chick Bad?
My Chick Bad, My Chick Hood.
You know what's fun?
There was a Polish kid I called, his name was Maciek, and I called him My Chick.
That's good.
Yeah, he hated it.
I bet he did.
Yeah.
You should have called him that.
It's okay.
If you take the word module and you inhale it.
I hate it when you inhale words.
But the module is a very good one.
I know.
Module.
Okay, get out of here.
All right, I'll be around. I'll just be kind of, hanging out. Yeah.
Oh yeah, I want you to stand there.
Is my head gone?
Yeah.
I will crouch down so it looks extra weird.
Move your Adam's apple as much as possible, so they can just see the gulping. Yes, I hope that's as off-putting as it looks from my perspective.
Oh, Ring Matthews. We
Ring
love
Matthews,
explaining
we
that.
can
You have
do
no
that.
idea what you just walked into.
Would you prefer this, or would you prefer? You want that after? Okay, great, sure.
And then we'll have Module 4 about Julius Caesar.
All right, so we have 9 is less than 15mz minus 8. 9 is less than 15m. Is it x or z?
X.
Why did I get z from that?
I don't know.
Mx minus 8 is less than 27. So, m is a positive constant. It's maybe important to know that it's positive. And what is the possible range of values for this expression including m? So here's the situation. There are two ways you can go about this. There's the more straightforward way. You solve for m. Now you're not going to get a value, but you'll get it. It'll be in terms of x because you have two variables here. M is not a variable, but if you solve for the range of values it could be, the answer will have x's in it because you don't have a value for x. You can do that. So let's do it this way first. So I'm going to add 8 to all three pieces. And you can do this with, then if you have two equal signs or two inequality signs, it's fine. You just do everything to all the pieces. So we get 17 is less than 15 mx, which is less than 35. Then we're going to divide by 15x with all three pieces. And that's what you'll get. So you'll get 17 over 15x is less than m, which is less than 35 over 15x. Now I think this might not be the best way to do it, and there is a nicer way to do it in my personal opinion. But this is what m is. So you're going to take this guy, because this is the extreme value of m, although it's exclusive. You put this into that expression they give you, 8 over 3 minus 5m over 5mx. So with that, what we would do, we would put it in. So this piece then becomes 8/3, and this is not the fastest way to do this. Minus.
Can I do the other way while you're doing that?
Yeah, well, you can do it. You can do it. It's fine. It's fine. It's fine. So you get 8/3 minus 5 times this thing times x. So we get 5 times 17 over, and it's going to be x there, over 15x. Okay, so that's clumped together. That's what the expression is that we want. We just put our extreme value of m into that value of m up there in that expression. Then we're going to do the same thing for this one. Or let's simplify this. This simplifies to Well, the x's cancel. This cancels with this and becomes 3. So you get, and then now we actually have a common denominator, so that's great. We have 8 minus 17, which is negative 9, over 3. Oh, wow, this is great. So this is negative 3. That's actually pretty straightforward. So that's our extreme value here. So negative 3 is our extreme. And so that looks like our answer will be A.
All right, what I'm doing here is instead of solving this for m, I'm trying to solve this for 8/3 minus 5mx. So you're actually not solving it for the variable, you're trying to solve for another expression. So we just have to somehow move everything around so that we get 8/3 minus 5mx. So I'm going to start where Levi, this second line right here. He divided everything by 15x. I'm not going to do that. I'm going to keep 17 is less than 15mx is less than 35. It's less than 15. Wait, what did I just do here? Oh, no, sorry, that's 35 right there. Oh my gosh, 35. And I'm going to try to get this middle to become 8/3 minus 5mx. So I'm going to divide everything by 3, because 15 divided by 3 gives us 5mx, and that's a good start. Everything has been divided by 3. This is 35 over 3, not 15 over 3. Oh, jeez. Okay. And then I'm going to multiply everything by negative 1, because that's going to give us negative 5mx, which is closer to what we want. So this will be negative 35 over 3. Now, a quick note. When you multiply everything by a negative number, or divide everything by a negative number, all of your signs have to flip. That is one of the rules of doing inequalities. All right? I didn't make the rules. I just follow them strictly, because it's math. All right? Last thing you need to do here is add 8/3 to every single portion of this, because that's the one difference between negative 5mx and 8/3 minus 5mx, is there is a positive 8/3 in there. So you add 8/3 to all of these things. I'm going to rewrite this. I'll rewrite this over here. So I will just not have a head for a second. You add 8/3 to all of this, and you're going to, that's positive 8/3. So that's going to get us to negative 11/3. Is that right? No, negative 9/3. Negative 9/3 is greater than or equal to 8/3. Sorry, I'm off the screen. I gotta get better at that. Negative 9/3 is greater than 8/3 minus 5mx is greater than, and this is going to be negative 27 over 3. So these are simplifiable. This is going to turn into negative 3. This is going to turn into negative 9, and that's what Levi got as well. That expression is going to be between negative 9 and negative 3. Is this a precalculus problem? This is not. No, this is an inequality problem.
Yes, so what's interesting about this is the normal way of doing it. It's a little bit weirder because your other values, or your value for m, because you're used to solving for a variable, even though it's not technically a variable, you solve for it, and then now you have to plug it back into a bigger expression. So they're not asking you, what's the value of m? They're asking you, what is the value of 8/3 minus 5mx? So you could do this and then plug it back in. I think that's too much work. I like this way better because it's a slightly different way of approaching the problem. But rather than solving for your thing and then plugging it into their thing, you just make one of the pieces of the original inequality look like what they want. You just manipulate the inequality until it looks like what they are asking for, and then you're done. Looks like my ears are huge.
Put your hand behind your back.
Okay. What do we do now? Okay. If my belly is itchy, do I itch yours?
No.
No, I don't itch yours? Are you sure I don't itch yours?
No.
Okay.
Just teach.
Okay, so let's erase this. So maybe get the squirt. Do a trick. That was a trick, Storm.
Yeah, what do you want, like a backflip?
We'll do a backflip.
Yeah, we'll do it.
I'll do the first half. Bird will do the second half, and then he'll take me to the hospital.
I'll take you to dinner.
Yeah.
Yeah.
At least take me to the hospital first.
Very good. Window capture, robots in the sky.
Okay, so now we're doing the sine of whatever is 90 minus cosine of whatever.
Absolutely.
Okay, this is actually really, really intuitive. There are a couple different ways to do it. I'm going to make you do the less fun one, Bird, which is the graphing one.
Oh.
Yeah.
Are you going to draw the triangle?
I'm going to do the triangle.
Fine.
You have to do the graph.
Fine.
Because guess why?
Why?
I don't know. There's not really any rhyme or reason to it.
Really?
Although we could rhyme it.
Yeah, graph and laugh. Doing a graph makes me laugh. Ha 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 ha!
I feel like everybody gets more sad when you do that type of thing. Like there's no mirth that's actually delivered to the world.
Right. Do you don't think I like that?
I don't like that.
No, I don't like doing
You're
it.
miserable
I'm
when you
doing
do
it for everyone else.
Yeah, and they don't like it. That's what I'm telling you.
I know, but I'm trying to get them to empathize with me because I don't like it either. So if everyone feels worse, then I feel like I've got, like it's like a misery loves company situation.
Okay. So if this is your angle, x, what is the value of this angle? We know that all of these add up to 180 minus x.
No.
Why did I say that? All of these add up to 180. So therefore, if this is 90, these two angles add up to 90, right? Because if this is 90, these two are 90 in total, that gives you 180. So that means that instead of this being x and this being y, this is the same thing as 90 minus x. You can't read that super well, probably. So knowing that is 90 minus x. Then let's think about sine and cosine. If sine is opposite over hypotenuse, the opposite over the hypotenuse, so let's say this is A, B, and C, sine of x equals A over C, opposite over hypotenuse. Well, cosine of 90 minus x, this is 90 minus x, the cosine of that is adjacent over hypotenuse, so A over C as well. So the 90 minus x, if you have an angle x and you have an angle 90 minus x, they are the other angles of a right triangle, right? So it makes sense with the ratio, the trig ratios, that sine of this one equals cosine of this one, and vice versa. Sine of this one, which would be B over C, is cosine of this one, B over C. Does that clear that up for you? Matthew asked that, or was it Storm? It was Matt, right? Oh, sorry. Did you? We do have a YouTube channel. Sorry, we didn't see that, Bon Bud. Did you see that, Bird?
You know what? I think I did, and I just was talking about something and I totally forgot.
Got it.
Yeah, we do, and you can have the information is below.
Below.
Does it work for cosine x? Yes, it does.
Yeah,
yes,
same deal.
You bet it does.
So cosine of x here. Cosine of x is B over C. Sine of 90 minus x is opposite over hypotenuse, B over C.
And then, that is my approach too. There's the graphical approach. I have about a period and a half of sine and cosine graphed on this thing right now. And what you'll notice is that they are, you can almost think of them as, I know parallel is not the right word. They're almost in phase with each other, but they're 90 degrees apart, all right? So when you start at the very beginning at 0 degrees, sine is 0, cosine is 1. And the time when cosine becomes 0 is when cosine is 90 degrees. So 90 degrees later, it's going to be equal to what sine was at 0. All right? At 0 degrees, sine is 0. Cosine becomes 0 at 90 degrees. And you can see there's a 90-degree separation between all of these, right? This and this right here, this is 90, this is 180, so that's 90 degrees apart. They're at the same point in their cycle. They're both crossing the x-axis, but they're 90 degrees apart. So there's a 90-degree shift between what cosine is and what sine is, and that was why they equal each other if you shift one of them by 90 degrees.
Yeah, so if you know about graphing sine, cosine functions, sine of x plus or minus 90 equals cosine of x. Because if you add 90 degrees...
I don't think it would be adding 90. You have to shift sine. You have to shift sine backwards. By 90 degrees.
It's minus. Well, this is technically plus 90 if it's a negative x.
Haven't you have so like negative degrees?
Yes. It doesn't matter. It's not
Well,
plus or minus.
if you had x plus 90, you think it's going to go to the right, but it's going to the left, right?
It's got to be plus. It has to be minus, right?
So
The sign starts here.
Would start. Well,
You need to pull it back. Yeah, so it is minus.
but if we want to go backwards, you have to add.
That's why you just put both.
But is it equal the same way? Because like if this is okay, so this is getting this at
No.
90.
I don't think we should not add 90 here. I think we should subtract 90. Right? Because cosine of 0 is 1.
Right.
Sine of 90 is 1.
Right.
So
We have to subtract 90 from sine. Because to get it back to 0,
if you plug in 0 for x right now,
you get negative 90.
you get negative 90. So
And that
cosine
would-
of x is 1. You need to make this equal to 1.
Oh yeah, negative 90. It does have a sign of negative 1. On the unit
Yeah,
circle.
but this is 1. That's why it's got to be this. That's why it's 90 minus x in those. Why is it that in both? That makes sense. I feel like we're confusing ourselves needlessly.
We are.
Do this. This makes way more sense intuitively, ideally. I don't know what I'm missing right now.
We like that, right? If they both have x as 0, cosine of 0 is 1.
This is negative 1. So that's not true.
You're right.
So that's wrong.
So it's 90 minus x.
Yes.
Okay, so or negative x plus 90.
Yes.
Okay, or you could do something like x minus 180 or something like that. Because x minus 180 is going to shift this thing all the way here. But they don't need to remember that.
Don't pay attention to anything we've said recently.
Yeah, this is not important.
Think
This is
about
more-
this.
Right, because minus 180 is going to send you 180 into the future. And that's going to get this to match up with that.
No.
You can go in both directions. Right?
Yes,
you can
but
always
minus
send this to
one-
being up
yeah,
here right
you
there.
should. 180 is not enough.
To get from here to here? So this is happening at 90, and this is happening at, this is 360, isn't it?
Oh, I see. I see what you're saying.
So it's 270. It's not
Yeah,
180, it's 270. All right, good. We figured it out. Don't worry about that.
Thanks for asking all of those things that you didn't want to know.
Back to logarithms.
Back to logs, unless we got more questions in the Discord, which I don't think we do.
Why don't you check the Discord?
Oh, I'm going to check the Discord. Nothing on the Discord.
Very good. Don't worry about this. Worry about that.
Just worry about it. Worry about it deeply.
And painfully.
Yes. Be a worrier. That's what my mom always said.
Be a warrior.
Worrier.
No, all right. Be a warrior. So you can't tell if it's warrior or worrier, right?
Be a worrier. What is a Brooklyn accent? I need to know a Brooklyn accent.
Coffee.
Like coffee. No. Like 50s.
What, you are in your 50s or it is 1950s?
In the 1950s, but yes, you are in your 30s actually.
Yeah, I'm in my 30s in the 1950s.
Yes.
All right, so that means
Is
that
there nothing-
I was born in like 1920?
Yes, but right now it's 1950.
What does that mean?
Like at the time of this accent, as you speak,
Yeah.
given circumstance,
Oh, I see what you're saying.
it is the 1950s.
It's like what did the
1950s Brooklyn. You grew up here.
I think of West Side Story, but that's still Manhattan. I just think of that's like the
I don't know it.
New
no.
York dialect, but I think they called it the Brooklyn dialect.
Shirts off our backs. Let's see, Brooklyn. Yeah.
When you're a jet all the way
I don't know that.
from your first cigarette to your last dying day, right?
I
Meet Tony and me
I
at the
don't
gym
know.
and look sharp. We always look and walk tall.
What's the answer, boys? Strike.
What is that
Well,
from?
what's the answer? That's from Waiting for Lefty. Let's see. Oh, can you talk about similar triangles? And then maybe compound interest.
Yeah, let's just go to that.
Sing the entire song, please.
I did play that part in high school. Actually, we were talking about that this morning. I'm
You
not
played
even
the
kidding.
newborn?
I was the newborn in West Side Story. No, I played riff. Curtains came up. I was standing there, just like. It was awesome. And then it turns into the prologue, which is not the Jet song yet. There's just a lot of dancing and fighting, which is what gangs do even today.
Yes.
There's a lot of ballet and things like that. And then eventually it gets to the Jet song. And that was fun, man. When you're a jet all of the way.
Okay. these two triangles are similar. Not because they have the same lengths, but they have congruent angles, okay?
Demonstrate the ballet. Psh. Dude, if I demonstrated the ballet, your eyes would melt out of their sockets.
Right out of
And
the
that's
sockets.
not what this stream is for.
Yes. Okay. Congruent angles, if you have 3 congruent angles for the triangles, then they're similar. Also, you only need technically 2 congruent angles, because if you have 2, then the third angles will be equivalent as well. What's a congruent angle? The measures of them equal each other. So congruence is, you just think about it as being equal.
It's geometry
Like,
speak for equal.
Yeah.
Yeah.
It's just when you say equal, that means those things are exactly the same. These two angles are not exactly the same. Their measures are equal. The angles are congruent.
And Ring Matthews,
just ignore that.
Ratios are similar. Whenever you see similar triangles, 9 times out of 10, you need to do a proportion to find a missing side length.
Yeah.
Which is setting 2 ratios equal to each other.
Yes. So you can think of it as, so if we have side A, B, and C, and then sides D, E, and F, we know that A over D equals B over E equals C over F. Now, this is not the only set of proportions you can do. You can also do, so this is little to big, little to big, little to big. But you could also do little over little, A over B equals D over E. Either of these work. It doesn't matter which one you choose. Just make sure you stay consistent. So if it's little to big, then don't go big to little. That's down here. If it's little and little, then do the corresponding sides, little and, or big and big. So that's the ratios between these triangles. Now, you look so much like Peter Parker from the bad third Spider-Man.
The one with Tobey Maguire.
Yes.
Not any of the recent ones. Well, he was cool in that one, so I feel like this compliment.
I've seen only negative things online about it.
All right, fine.
I've seen bits and pieces, though.
Now, the funny thing is, because everything is flipped in our footage, they think that my part is on the opposite side from where it actually is. You know, which is something to think about.
Yeah, and I'm now thinking about it. So that's good. Do you want...
They want a compound interest.
Okay, so do you want anything more
Let's do a
on
practice
this?
problem with this.
Yeah. Okay, so I got something for you.
Oh, yeah?
Yeah.
I got something, too.
Oh, okay.
All right. These triangles are similar, and the order that the angles are given when you write something similar to the other has to be the order in which they're supposed to. Anyway, just trust that A is to D, as B is to E, and C is to F, okay? There's only one side length we could actually find in these two triangles, which is this one right here. We have those two up top here. We only have one of these up top here, so we have to be able to solve for that one. That's X right there, all right? So, a couple ways you could do this. You could say 5 is to X. 5 is to X as 7 is to 9. That's one proportion you could set. You could also say 5 is to 7 as X is to 9, right? Whatever relationship you have on one side needs to match the relationship on the other. Do triangles in each other. What?
And that's it, like when you have a line here and you have similar triangles like that.
Oh, that's a great idea.
Such a good idea.
Anyway, so you set up your proportion, you cross multiply. This is going to give you 45 is equal to 7x. Divide everything by 7, and you get x equals 45 over 7. 45 sevenths, which is 6 3/7. Last time I checked, which was earlier today at like 5 o'clock p.m.
Yes, you did.
It might have changed. I have to check the markets. The markets have closed.
The value of 3/7 has changed recently.
We don't get on violence.
We don't.
I know.
We don't. At some point, you're going to just pull out a pistol and, you know, over the roar of the gun, say, we don't condone violence.
Are you sure it's not a pistol like the part
Yes,
of a
I'm
flower?
sure of that. So, be careful.
I like flowers.
Yeah. Be careful of this type of thing. These are nicely set up where they're just, This one is at a different orientation, but we're told exactly what's going on. Or you could be given the angles. The angles will tell you which sides are corresponding. So here, this 18 doesn't go to the 7. but we have, so this is side XZ. So these triangles, the written way of doing these is the correct relationship. So EF is this side and this side, the ends. XZ is the ends of this, so that's 18. So it's 18 to 9. So to figure out the other, it would have to be, to find what ED would give you, ED is these two, so it would have to be XY. So you could find this side. Let me know if that doesn't make sense, but you want to do this one?
Absolutely.
That's not what he was talking about, but that's
triangles in each other.
Yeah, I'm assuming he was talking about a parallel one, so I'll do that.
Okay, you do that one. Yeah, okay, so here's two right triangles. Actually, there's three right triangles here. All right, we have the very big one, and let's say we wanted to solve for this right here, that value of x. It might be that there's another value I have to give you. We'll see about that, okay? So that value of x right there. Now, here's the thing to notice. If two triangles have two angles in common, their third angle must be congruent to the other third angle, because everything adds up to 180. So if two of your angles are set, the third one is also set because it needs to make up the difference up to 180, and the other triangle will be the same, okay? So let's take a look at this angle right here. This angle proves that this overall triangle is congruent to this small triangle right here, and I will tell you why. The overall triangle has the right angle, and it has this angle. This small triangle has a right angle here, and it has this angle as well. So therefore, these triangles have to be similar, and the angles that we're not talking about right now are going to be, this angle would be similar to this angle down here, okay? So let's see what we can do here to solve for x. 5 is the hypotenuse of this small triangle. One of the side lines we can figure out is the hypotenuse of this large triangle. This is 5, this is 12. If you know your Pythagorean triplets, you know that the entire length of the hypotenuse would be 13. If you don't, you can do Pythagorean theorem. 25 plus 144 is 169. Square root of that is 13. Okay? So we're trying to find x here. You have to make sure that you line up the side lengths with the ones that they're similar to correctly. Okay? So let's say that we do 5 over x. Let's think about what sides that would match. So 5 over x, we're using the hypotenuse of the small triangle. All right, and then we're using the side length here. 5 over x is going to be equal to, the thing that's congruent or similar to the 5 would be 13, because that's also the hypotenuse. But watch out. Which side is x going to be congruent to? X is between the right angle and the blue angle. So the one that's in the same place in the large triangle is between the right angle and the blue angle. That's 12. This side goes to that side. This side here goes down to the 5 side. Yes, goes down to the 5 side. So 5 is used actually in two purposes. It's the bottom of this large triangle, and it's the hypotenuse of the small triangle. But the thing that our x is going to be similar to is this 12 here. All right, you set that up. You've got 60 equals 13x. You got x equals 60 over 13. And you got yourself a good time. All right, this is not a great 3. There, it's a better 3. Cross multiplication. It's what's for breakfast. Along with a bowl of cereal, but instead of milk, Levi's blood. Very, very nutritious. Lots of nutrients. Nutrient.
Okay, so now we have this situation. All of these lengths that are written in here are just for that. So this 8 is only B to C. And let's say that the question is, what is the measure of AB? That's what we want. AB equals something. Okay? So to get there, we're going to use similar triangles. There are a couple, there's one similarity here because there are two triangles. We got this little one inside this slightly bigger one. There is a very common mistake that people make here, but we're going to set up a ratio. So we have this triangle. It's going to be similar to that triangle. They're similar because they both share this angle, so that's 1. And then because I've marked that these little caret things are not part of the 9 and the 6, they're part of these lines, and they show, or segments, they show that they're parallel. Because they're parallel, two parallel lines cut by a transversal means that corresponding angles are congruent. So these two angles are congruent, and these two angles are congruent. So now we have similar triangles. So now we're going to set up our ratio. And I'm going to call this x in here. Okay, so that's x, that's what we're looking for. Now, 6 over 9. So we're doing the little triangle over the big triangle. 6 over 9 equals, it's going to be this side, because we want to include this. It's going to be 8. It's not going to be 8 over x. This is where most people make the mistake. They make it x because they say, oh, it's the 6 to the 9 and the 8 to the part of the bigger triangle. But that's just a piece. The similarity, the proportion is side lengths of triangles. This AB is not the side length of a triangle. So in this case, the bottom would be 8 plus x. Okay? Because it's that whole thing. Now we can solve. We'll cross multiply. So we get 48 plus 6x equals 72. And then we'll subtract 48 from both sides. So we get 6x equals 24. Thanks for the follow, Durander. Do you want to ask some questions? Questions? Any questions about anything? Ideally the SAT or ACT? Just listening. Okay, keep listening. Very good. And then we divide by 4, so we get x equals 4, and that will be the answer. Or you could use, if you were to use the variable a here, you solve for a, you would get, I don't know what you would get. I do. It would be 12. But you could use, so let's do that. We could do 6 over 9 equals 8 over a, where a would be the length of this whole side here. If we were to do that and solve for a, we would eventually get that a equals 12. That's not the answer, though, because they're asking for the length of AB, which would be this. So then you would have to remember it's 12 minus this piece, so it would be just 4. Okay? This is easy to miss, that this is not part, you can't just do this variable x in your proportion, because the proportion doesn't take that into account. It's the entire thing that you have to use. What you can do to avoid that is you can break out your triangles. So write them as 2 fully separate triangles. They don't have to be drawn to scale, obviously. But we'll call this one, the little one, B, C, D. And we'll call this one, the bigger one, so A, C, E. And then you label your sides yourself. So this is the small one, we have 6 and 8. This is the big one, we have 9. And let's call this would be A. So then you could solve for this A this way, and this would be a little bit clearer. You have 6 to 9 there, 8 to A there, and then solve, and then you can superimpose it back on. So there are a couple different ways. I think when you see these, if you're just practicing, break it out like this, or do it without breaking it out because it's a little bit quicker, obviously. But then break them apart if you're having trouble visualizing, because then you have them separate. You can compare them better. Okay.
There is a question on the Discord.
I see that. No, Matthew said it's too easy.
So he's got it now?
Yeah. He posted it and then said, wait, never mind, it's too easy. So we're not going to do it.
Yeah, I guess not.
So Durander, I know you're listening. Are you prepping for the tests, or are you just listening, or is this actually benefiting you, aside from how exquisitely fun watching this stream is?
Exquisitely fun.
Exquisite fun.
We're more than halfway through, so we could just say that we did basic logs and forgot properties. If you want to get started with reading.
Okay, I mean, I just put reading because I put reading. I don't really have anything to do.
Oh.
Yeah. I've been doing a lot of reading with Matthew, actually.
I love reading with Matthew.
Yeah. Any other questions?
Watch it.
Sorry. It's a good point. It's a very, very good point, Bird.
I'm Bird.
You are.
You know,
Dang it.
Bird.
I really hate my contacts so much. They're super useful, but if I have them in for more than 6 hours, I get a headache.
Oh.
Yeah.
We got a question.
We do. In the Discord?
Yep.
Ooh.
Big time.
Nice. This one's from Reddit. What do we got here? Oh no, it's from. Wait, where's the question?
The bottom.
Okay. Don't care about this either, right? Okay, how pixelated is this? The picture's pretty obvious. All right. So we have point C is the center of the circle. Great. What fraction of the area of the circle, I can't read that, is the area of the shaded region?
So I see what you put, and I see what you did wrong, which is you divided the wrong way. You thought this was asking 360 over 100. It's asking 100 over 360. And it's the way that the question is asked that you have to pay close attention to. So like if I were to say something like, what fraction of 10 is 5? That's a question mark. What fraction of 10 is 5? Okay, simple question. We want to say 5 over 10. 5 is what fraction of 10? 5 is 1/2 of 10. All right? So you could almost think of this in terms of 5 is what fraction of 10? And then the order, this isn't my problem. So wait, just asking how to do this in general? Because I saw what you put, and I just thought that's probably what the mistake was that you made. Okay, in that case, if you just want to know in general how to do this, 100 degrees is the degree measure of the sector, and that is a fraction of 360. Whatever your fraction is, whatever the angle over 360 is going to be the fraction that your sector is over the entire area, okay? So like, you have a circle, you have a sector that is 90 degrees, that means that that's 1/4 of the whole circle. Number one, because it looks like it, but number two, the more important one, 90 degrees over 360 is going to give you 1/4. There is a couple ways to think about that 1/4. Number one, the arc length here is going to be 1/4 of the overall circumference, but also the sector area, this pie slice here, is going to be 1/4 of the entire area. So it all comes down to this right here. You take your angle, you divide it by 360. That is going to give you the fraction that all of these measures are going to be of the entire circle. Okay? So 100 over 360. You can simplify that. I know you don't see my head right now, and I'm okay with that. All right? They're both divisible by 10. We'll start with that. 10 over 36. They're still both even. I can divide those by 2. You get 5 over 18. 5 over 18 is... Now, when you say this isn't my problem, do you mean like you didn't post this? Or... Because I'm not sure I said... Did I say, Ring Matthews, this is what you did? I don't know if I said that. Whoever posted this, I saw the answer that you put, and that is what you would get if you flip 360 over 100.
Matthew
instead.
did post it, but it may not be his question, because it's from Reddit, so...
Oh, okay. All right, does that make sense? If it does, we can move on. Loggia. Loggia. Oh, it looked hard, but it's actually not. Hey, that's great. Yes, yes, it's actually not hard. It's actually not. Now, if they're asking you for a specific area, what's the area of the shaded region, you'd have to know the radius of the circle. Because otherwise, all you know is that that's 5/18 of the circle. You'd have to know the radius of the circle so you could figure out what the actual area of the circle is and then take 5/18 of that. But that's not what they're asking. They just want a simple ratio or a simple fraction. Very good. I will erase this now. And turn this off. Any other questions, Leave?
No.
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 No. No, you not have a question? You look like Australian Kermit.
Someday we'll find it, the rainbow connection.
And then throw Australian in there.
Someday we'll find it, the rainbow connection.
That's it.
Yeah, a couple of guys just hanging out, doing math problems.
That's Australian Kermit. I've never put those together before, and I like it. This is drawing it out. I'm not just doing this, but I am kind of just doing this because it's fun. You get a lot of fun out of
Bird,
that.
you can't tell them that type of thing.
Sorry.
Gives them too much power.
Oh, jeez. You're right. Sorry, Levi. I just gave it all away. I have a habit of doing that. Oh yeah, what is that? CB Turtle?
Mm-hmm.
I miss CB Turtle. I miss singing CB Turtle. I miss tucking CB Turtle in at night.
Yeah.
CB Turtle, a bedtime story. Yes. Any other questions? We're here all week, except for not for another 4 days. So that's not totally true. I mean, we're physically here, but we're just not streaming. He and I are just hanging out behind the board, eating sandwiches and talking. We're just not streaming. So we are here. Yes. Levi, you want to get up here and talk about something?
Do I?
Do you? I'll talk about logs if you don't. Ba-da-da-da-dum.
Oh boy.
Ba-da-da-da-dum.
I stood up too quickly.
What? You stayed up till 2:30?
I stood up too quickly.
Oh. Why'd you stay up till 2:30? Do you have a dentist appointment at 2:30? Because it was 2:30? There was some contact
You
made.
don't condone
We
violence.
don't at all. You know what we can also do? A little bit of this. Whoa!
Oh, we could.
Yeah, you like this.
We haven't done this in a while.
Yeah, that's the whole point. Number 15, that's a good one.
Could you blow it up a little bit?
I don't think I can. This is not...
Matthew sent one in Discord.
Oh, okay.
What's that? This is some.
It's none of
other
your
thing.
business, which is sovereignty, legal speak.
Oh my god.
SAT humor.
Verdi.
Yeah. It's none ya. None ya, what is that? None ya business. That's from something, I don't know. What's the question, Levi?
I'm
I'm gonna pull it up on this while you're looking for it.
I don't know why my phone's being so slow.
Pretty woman, yeah, yeah, yeah.
Ooh,
This
bird.
looks kind of fun.
For a triangle problem. Nah, 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 nah. What is the length of NQ? So we're looking for this thing here. So how do we find it? So Bird, you told them that all of the sides, or the three triangles here are all similar to each other, right?
Yeah, I was talking about that.
Yeah. So all three of the triangles in this picture here are similar. When you have a right triangle with an altitude to that right angle, you're good. Okay. So we are going to say we're going to try to get NQ. Right, so because that angle is shared, yes. Yeah, okay. So I'm going to pull these triangles apart. It might be a little bit clearer. Maybe I won't. So we have this triangle MNP. Okay, so triangle MNP, I'm going to bring that up here. That's 3 and 4, MNP.
Hypotenuse.
And then, what?
This is the hypotenuse. 3, 4, 5.
And then, oh yeah, this is going to be 5. So that's good to know. I'll put it in parentheses because it's not given, and I don't think we actually need it. No, we don't.
Yeah.
And then this other triangle, I guess it doesn't matter which one we do. So we have the big triangle, and we're going to have those two sides. Now, we can choose... No, it does. Yeah, we want this guy. No.
I don't think it matters. They both have the hypotenuse.
That's true. Okay, so let's take M and Q. M and Q. But I'm going to say that this triangle MNP is similar to triangle M goes to the... They share this angle. Angle M is shared by them, which means that angle M has to come first.
But it's then QN.
And then it's going to be QN. No, it's not.
Yes, it will. Q is the right angle for the small triangle.
Oh, for this. Oh, then I mislabeled this. That's what the problem was. So we have Q and N. Thank you. There you go. So M, N, no, MQN.
Yes.
Q and then N. And we know that this guy has a 3 here. And we want to find this. So let's put an X there. And now we're done. Now we can just set up a proportion, making sure we have the right corresponding sides. So let's say 3 to 5, so the two hypotenuse. Hypotenuse. Okay. So 3 over 5 equals X over, this will be the NQ, so it'll be NP, which is 4. And then we multiply by 4, and we get 12 over 5 equals X.
2.4.
2.4. Do you have any questions on that? You could keep it all in here. It's just I like blowing it up because it makes it a little bit more separate. Are you okay?
Yeah, man, gravity.
Gravity pulled you down there.
Yeah, the gravity for a second became perpendicular to its usual direction.
Got it.
Hey, that's pretty exciting. That's all sorts of terrific, Levi.
Hey, bird.
What?
What's this?
What's that?
It's actually accelerating.
Well, yeah, let's wait.
Okay.
What's that?
That's Alta Ipsum.
Here, let's do this.
Is that our private tutoring coming? Okay, so Alta Ipsum over there is our sponsor for this video. And you know when you advertise for a sponsor and you get someone's hot breath on your neck? I have that feeling right now. But also don't pass out from not breathing, Brady. Oh, it's so warm.
Let's go.
Your breath. Alta Ipsum. It is. Oh, sorry. Forgot. It allows you to track your grades. It allows you to put in your schedule. It allows you to put in your schedule and then track your grades in that order as well. You can put in when you're going to take a test, when you're going to write an essay. I always say passage now. And it'll set up study schedules for you. You can outsource your planning to that thing. It'll tell you what to do. Therefore, you can focus on the really important stuff, like watching Nerdish and playing hoops and shooting pool and slaying your enemies.
And it's free for a month.
It's so free.
A whole month. That's like a 12th of the year. That's huge.
It's just like that.
That's like a 12th of a year, which is like, what is like an 80? What's the current lifespan in America?
It's 76, right?
76? 76. So that's like a 12th of 70. It's a 12th of a year, which is 176th of your life.
1776. So that was 400 years ago.
You take 176th, which is 1 year of your life, multiply it by 1/12, and you get 1 over, here we go, 70 times.
Wait, I thought you were asking about how old the U.S. was. Was that wrong?
No.
How did I get that from
I
what you
don't
were
know.
saying?
I don't know.
Then I was saying the U.S. started in 76. That number was wrong. That was based on when the U.S.
What's the
declared
lifespan?
Independence.
That's what you're thinking of. No, I'm asking what's the lifespan of an American?
Oh, because you said America. You said America. I thought you meant America.
No, I understand. I understand. 76. What's the lifespan of it? Is it like
No,
80?
but I thought you meant...
I understand what you thought I meant, but now you should know what I mean now. What is the lifespan of an American now?
Don't yell at me, Ferd.
No.
We don't condone yelling.
We condone yelling, we just don't condone violence. What's the... Let's just say it's 80. You're going to live 80 years, all right? Maybe with modern medicine, we'll make it 90. How about that? You're going to make it 90.
Don't set their expectations so high.
Well, modern medicine, it's modern. It's not from back then. 9 times 12, that's 90 plus 18, which is 108. So that's 1080 of your life. I think I have that right.
For free.
For free.
The rest of your life you have to pay for.
But think about it. You're not going to use Alta Ipsum up until you're 10.
No, I'm saying your life you have to pay for. Alta Ipsum is free.
For a fraction. 1/1080th of your life.
Might have gotten
Who could be calling you at this hour?
It's my kids.
And our other sponsor is Tide Bond Original Wood Glue. You just look at the sticker that came off.
Notice how I didn't have glue on my finger and I dropped it. Make sure if you don't want to let something go, like wood or other wood or people, glue yourself to them.
With Tide Bond Original Wood Glue. Because Levi and I have a Tide Bond. No.
Okay, Bert.
We should fill that up with something. Let's do those math things. Oh yeah, we can do the math things.
Ow.
Sorry.
What math things are we talking about?
The thing that's, this stuff.
Oh, math things. Yeah. Can you blow that up?
No, you can't.
Yes, we can.
Oh, that's what you meant.
That's exactly what I meant.
I didn't
said
think
that.
you meant that.
You thought I meant something else.
Yeah, and I thought when
Well,
you...
why didn't you understand what I said?
Well, you thought that I was talking about the lifespan of America, which you can't even ask that, because who knows when it's going to end.
Thus far.
Right.
How far has America's life spanned?
Oh,
What is the area of the triangle below?
Easy. It's an isosceles triangle at least, because 10 is matching 10. Therefore, this angle here needs to match... Oh, interesting. This angle here needs to match this angle over here, which means these are both 60, which means this also is going to be 60. Law of sines. You could use the law of sines here. That will tell you missing angles and missing sides, but at some point, you're going to have to bite the bullet and find the area. So you could say it like that. What are you drawing there? What is that? What are you doing? What is that?
So, it's very important to remember the law of sines, but also don't confuse it with the saw of lines. This is the saw of lines. It will not help you on the SAT.
You just think of that?
Yeah.
That's very good.
I'm glad you like it.
The saw of lines.
Yes.
What about the saw of signs? No.
Yes.
Law of cosines.
Law
The
of
caw
The car.
of low signs. Low signs up there. Caw. It's the caw of low signs. I feel like that's how you gather together a group of superheroes as they hear the call of low signs.
Yes.
And they know it's time.
The car of low signs, sir.
It is sounded, we must congregate.
And how does it sound again, sir?
Caw, low signs. That's how you know.
That's how you know.
Yeah.
Yeah, just careful. These are very sharp.
Yeah.
Yes.
They cut lines with them.
They cut on the pull, not on the push. They're like Japanese handsaws.
Yeah, we in the business
Of tutoring.
tutoring, we use them, but we put them behind one of those you gotta break the glass to use it, so we only use them when they're very, very necessary. Anyway, so we got a triangle here it's an equilateral triangle, all the sides are 10, and if you look closely...
Number 14, please.
What?
Please, number 14.
Oh, they asked?
Yes.
Oh, jeez. If I had put 10 on this side length just now, you know what would have happened?
What would have happened?
I'm gonna say...
More clarity?
Yeah. This is also brought to you by Claritin Clear. For those of you with allergies, take Claritin Clear, and your allergy symptoms should go down a little bit at least.
Also, you must have a mouth. Otherwise, you cannot take Claritin Clear.
After 15 is fine, LL. Ring Matthews wants to do 15.
Ring Matthews is fine.
With 15?
LOL.
Oh my gosh. All right, we'll do this really quickly. All right, we got 10 as well. Fantastic. We're made of two triangles here, okay? We don't know the height of this triangle, but if we look at a 30, 60, 90 degree pattern, this is 30. If you remember your 30, 60, 90 triangles, opposite the hypotenuse right here, that's 2x. Opposite the 30, that's just x, which means that this is 5. And then opposite the 60 is x root 3, which is going to be 5 root 3. Great. Now, that's not a great 5 root 3, but now we know the height of this whole thing. So 1/2 base times height. The base is 10. The height is 5 root 3. 1/2 times 10 is 5. 5 times 5 is 25. 25 root 3.
Root 3.
25 root 3. Fantastic, which is A. A is for apple. Apple is for Johnny Appleseed, which is actually one of Levi's ancestors.
I am very related to Johnny Appleseed. His brother was my great one of those grandfathers. Real last name was Chapman. Little known fact, Johnny Appleseed had many children, more than Genghis Khan. They were apples. Is it an equal? Stop it. Is it an equilateral triangle? Yes, it is.
It was an equilateral triangle. Yes.
And it will always be.
Very good.
Number 14.
Is your question? Wait, do you want to know why it's an equilateral triangle? Were you able to see that? How do you know? Okay, great.
Oh, you don't know this. So, this is an isosceles triangle.
So far as we know.
Yes, as far as we know, because they've told us. What have they told us?
They told us that both sides are 10.
Right. We don't know the third side, but we know these two are 10. So,
the angles that are opposite the congruent side lengths must also be congruent.
Yes, that's what we know about isosceles triangles.
So this is 60 and this is also 60. And then because of the law of 180, which is, they don't refer to it that way.
This is 65.
That's not true, Levi. Don't confuse them. That's 60.
Oh, okay.
That's 60.
Oh.
Fix it.
So this
Fix it. Fix it. Ring Matthews, does that make sense? Ring Matthews. Rings on your fingers.
Name Matthews?
Hang on, that's 60. This one here or this one here? This one, these two side lengths match each other. Okay, so it's a rule with isosceles triangles. Isosceles triangles have two sides that are the same. If you know that there are two sides that are the same, then the angles that are opposite those side lengths need to be the same as each other. Take a, what is Levi doing? Is it a hat? It's a dense hat. So this, therefore, has to be the same as this because these two side lengths match each other. So the angles opposite them, 60 and 60, have to match each other. Ah, very good. Okay. Reminds me of the show Doug. Cartoon back in the day. I'm making references for kids that are just too young. I'm not sure why I'm doing that. What? Oh, it's a midriff.
Yes, this is you, Bird, by the way.
Is it?
Yes.
How
And I'll
do you-
show them very
because I'm a
obviously why
dunce?
it's you.
Oh, Mr. Muscles. Oh. Yep, Mr. Muscles.
You have a sausage arm on this side.
Wow,
It's
my
got
forearm.
two elbows.
That's fantastic.
Yes.
All right, so you're asking about number 14. Which of the following statements must be true about the x and y coordinates to satisfy the equation? La, da, 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 da. Fantastic, fantastic. All right, so if you look at all of our answers, they've solved all of them for x. All right, we've got a couple inequalities. We'll see if that shows up. I don't think it should.
This is the law. This is the saw of lines.
Oh my gosh,
Yes.
am I okay? I
Yes.
feel like I'm in danger. So we want to solve this thing for x, okay? Because all the answers, they've solved them for x. So we have a y plus a x is equal to 0. Is that the order they gave it to him in? Yes. Solve this thing for x. We gotta get rid of a y. Gotta move it to the other side. So we're gonna have ax is equal to negative a y because I subtracted it. Last thing to do to get x by itself is divide everything by a. The a's are going to cancel out, leaving us x is equal to negative y. Negative y? What? What's so funny?
It doesn't look like the saw of lines because the saw of lines always has to be pointed away from yourself for safety. So this
Right.
more looks like a wireless.
Comb?
No, I was gonna say a wireless shower head.
Oh,
Yeah.
right, where the water just stops.
No,
Like
it
an inch away?
starts there.
Oh, so we just took
This is
a
the moment
picture.
in time.
Got it, okay.
T is 0.01.
Got it.
0.1.
It could be 0.01, depends on the
Nah.
speed of... Wow, that's really impressive.
Did you see
What
that?
about this? What about this? Ready?
Yeah. We don't condone violence, sir.
Come on!
I didn't mean to, and you would have dropped it anyway. We
You
have
don't know
proof.
that.
We have proof.
You don't know that. Ring Matthews, does this make sense? If it does not make sense, please press 1. If it does make sense, please press 2.
Por español.
Marca el 3. Beep. So you gotta
We're
put it
very
here.
happy to see you.
If you'd like to speak to a representative, press the pound key.
For help cheating on the SAT and college admissions, press the pound key and hold it down forever. I don't know where that's going.
Well, then you prevent it from cheating because they just always hold
Yeah,
that
just
thing.
hold it down until you get it.
Good.
to the
Ring
palette
Matthew
to
says
do it, yeah.
2, so that means that it makes sense. Levi, what time is it?
It is.
I grow weary of this activity.
Why that's so funny.
What time is it?
I grow weary of tutoring.
I want someone to feed me grapes as I lie upon one of those furniture things. Hey, it's Chesky! Chesky 2. Chesky 2, coming at theaters this spring. It is spring, isn't it? It's summer. It's almost summer.
No, it's been summer.
No, it's not. June
Yes.
21st. June 21st.
Oh, really?
Yep.
Wait,
It's not summer yet.
I mixed up the first day of spring and the first day of summer.
Yeah, you did.
I thought this on leap
Do you
years.
see what I have to deal with on a 3-night-a-week basis? Do you see?
We don't condone violence.
Yeah, I'm sure. Chesky, how you doing? You got any questions?
How many questions you got?
Maybe we won't answer them. Maybe we
Did
will.
you bring enough tonight?
We
don't
don't.
want it what happened last night.
Yeah, to Davey,
We call him kneecapless Davy.
because we busted in his kneecaps.
Right.
Except we did it with a feather, so he just kind of laughed and stuff.
Because when you put them together, they make 2.
Why is 1 plus 12? That's not a question. Why is 1 plus 12? Nope.
The correct question is wherefore is 1 plus 12? And the answer is similar.
We'll
to
tell you, 1 plus
why-
12 is 13. Why would you ask that? Because you're adding lengths. 12 inches and 1 inch gives you
Yeah.
13 inches. So that's something.
Why not 3, my lord?
Why not 3?
Why not 3, my
I
lord?
don't know, my
I
lord.
grow weary.
No, it's more like I grow weary of this activity. Of this free tutoring. I wish that I could give them money to watch us. To make it not free for us.
Similar to what we're doing.
Yeah, true. Time is money.
And money is time.
And money is sweet money.
Yes, it's so sweet. And
Yes.
money is nutrients.
Nutrients.
Nutrients?
I love nutrients. I love them. As long as we do unrecognizable accents, we're fine.
I love them.
I love nutrients.
Is that Groot and a Minion put together? Not Groot. Who's the guy in Despicables?
The despicable.
The
You mean
despicable.
despicable me? When you say an animal can see these subtle differences in a human's face, does it mean subtle, fine, and delicate, or subtle, difficult to understand? Oh. Fine.
Probably
Fine and delicate.
Fine and delicate.
Yes. Now, we would never say that. So I don't really know what I would mean when I say that. But I can assume it would mean fine and delicate.
Yes, so both would be fine.
But animals would need to understand the differences. That's the thing. All they do is that they can see. It was on my state test. Compound interest. Compound interest!
Compound interest! Ring Matthews, you totally forgot about this. Ridiculous. Dude,
What?
you need to write with the other hand.
What do you mean?
Why don't you just learn to write backwards?
Why don't you?
Because I don't need to.
Hello.
Oh, hi. How? Ow. Yeah, I shouldn't have done
A equals P times 1 plus R% to the T power. This is the formula for compound interest if it is only compounded once a year. We're going to start with that. All right. P is what's called your principal. This is the amount of money you put in to start. Principal. Not like the principal of your school. It's, you gotta watch. You don't want to get in trouble. All right. Principal is the amount you start with. Starting amount. Very good. R% is your percent interest. I guess interest rate. Interest rate. That's what it is. Levi, what time is it?
9:21
All right.
p.m.
Oh, sure. That is your interest rate. And T, sweet, sweet T. Sweet, sweet T. That is the number of years it's been. The number of years. Shouldn't R be not a percent? All right, good question. So I write it like that just so kids know what's going on. All right, technically you should have R over 100. if you have an interest rate, let's say you have a 6% interest rate. All right. 6% as a number is 0.06. So what it's going to mean is it's going to be P plus 0.06 to the T. R percent over 100, you mean? Yes. Yes. Good. I mean, the fact that you were bringing that up means your head's in the right place here. Oh, jeez. R percent over 100. Yes. All right. So, this gives us principal times 1.06 to the T. The T. R percent over 100, yeah.
Why not 3 million?
I don't know what that refers to.
Why not 3 million?
You've never been this adamant about 3.
Why not?
You want the P to be 3?
3 million.
I don't know what you want from me.
Why not 3
All right.
million?
You invest $300
million.
You've got.
Well, you already have. You said $300 dollars.
No, $300.
That's what I said.
At 4% interest rate. You're wondering, after 5 years, how much money you're going to have. 300, 1.04, taken to the 5th power. All right? Put that in your calculator. Tell me what you get. It's late. I'm cranky. I haven't watched my stories today. 1.04. Now, the reason why we're multiplying by 1.04 is because to increase something by 4%, you could either first find 4% of that thing and then add it back to your original amount, or you can just do it in one fell swoop, multiply by 1.04. That's going to increase something by 4%. We're doing it 5 times. Every year, we're taking something and we're increasing it by 4%. Ring Matthews, what is the... Is it the setup? Is it if you need to solve for t? Because that's always a fun one. Like, if your question was, how many years is it going to take for your money to double? That's a fun question, all right? That's a fun question. So the question here would be, for those watching, don't forget negative rates is 1 minus r. For those watching, please forget that negative rates is 1 minus r. I'm kidding. Ring Matthews, thank you. Thank you. Yes. If you are, so like, for instance, population decay is when your population starts going down. If you go down by 5%, for instance, your population, 1 plus a negative rate. So you can think of it as 1 minus r, or you can think of it as 1 plus negative r. If you're going down by 5%, this is going to be minus 0.05 to the t, which means p times 0.95 to the t. Every year that you go down by 5%, you can also think of that as you're going to go to 95% of what you were before. Knock off 5%, what's left is 95%. So you keep taking 95%. I don't really have issues with it, just you talking about it helps me remember it. And you gotta be honest here, me talking about compound interest makes you, it makes it easier to fall asleep, I'm guessing. I do a practice test this weekend and bring actual problems for you on Tuesday. Ring Matthews, that is an excellent plan. That is an excellent plan. You are taking or getting the most benefit out of this possible by doing that. So we're big fans of that. Yeah. So if your question was like, oh geez, let's keep with the population. It's going to be going down 5% each year. And we're asking, how long is it going to take for our population to be half of what it was before? Our population starts out at a healthy 1,000 individuals, all right? 1,000 times 0.95 to the t. We're wondering, when is this going to be equal to 500? All right, set it equal to half of what we started with. That's what we want to find, okay? Divide everything by 1,000. We're going to get 0.5 is equal to 0.95 to the t. We're trying to get the exponent by itself, because that's what we're solving for, the exponent. The thing that you do to separate an exponent from everything else, the beginning of this lesson, if you were paying attention, is logarithms. Rewrite this as a logarithm, okay? For those of you that want it to be the same order that we started with in the beginning of the lesson, you'd say 0.95 to the t is equal to 0.5, and that way you can remember you're just switching the t and the 0.5 to get log 0.95 of 0.5 will be equal to t. Okay? And I will place that in the calculator. The calculator, my lord. The calculator. 0.95. No, not 95, you fool. 0.9. Not negative. Oh my gosh.
Why not 3 minutes?
0.95. Yeah, good idea. 0.5. Enter. It'll take 13 and a half years. We have 13 and a half years until we have half of the population that we have now. And for those of you that are wondering how much money we're going to have at 4% for 5 years, 300 times 1.04 to the fifth will be, enter, $364.99. It's actually rounded up, so around $365, which is incidentally the number of days you have in a year. Well, a calendar year. It actually takes the Earth 365.24 with some change days, which is why we have the leap year. Oh, can you talk about the different exponent rules when you add / multiply the bases? Are you talking about log rules or just exponent rules? Because they're technically equivalent, but you have to think of them very differently to understand them. So you want us to just forget logs for a second, go to exponents, or do you want the log properties?
We got 2 minutes.
We also have 2 minutes. Like a to the n plus a to the n. Ah, okay. Yeah. We can talk about that.
Well, there's nothing you can do with that.
You can do something.
Impossible, my lord.
Okay. So if you're adding them together, they're technically different terms. That's like adding x squared plus x together, which you can't really do much with, except you could factor something out of both. That's really all you could do here. Okay? Not sure what you mean by log properties. Log properties, like log of a plus log of b is equal to log of ab. That's one of the log properties. If you add two logs together with the same base, you can just put the numbers in parentheses and have them being multiplied. You turn it into one log. But that's not what you're asking. You're asking something like this. A to the 100th plus a to the 50th. What could you do with that? The only thing you could really do with that is factor out the least common factor. Sorry, the greatest common factor. Whew. Which would be a to the 50th. You could take an a to the 50th out of both of these. And what you'd have inside would be a to the 50th plus 1. That is all I need to do. I need to get some better markers here. That's all you could do. There's not much else you can do. You could whimper in a corner and wait for your teacher to pick you up. And I don't know, that's what you could do. There's not much else you could do. Your Matthews doesn't answer your question. I think what you're thinking of is when you multiply. Because, yes, that's what I thought. And yes, that is the rule right there. That's the rule right there. X to the 5th times x to the 7th is equal to x to the 12th. You add the exponents together. X to the 5th taken to the 7th power is x to the 35th. You multiply the exponents together. If you want to do, oh, I don't know, x to the 7th over x to the 5th, you subtract and get x squared. Now I could talk about why you do all these things, and what it's going to come down to is just expanding all of them and seeing what's happening. Log rules and exponent rules on Tuesday. Yeah, we could. Ring Matthews, that sounds fun. Levi, log and exponent rules on Tuesday. Don't forget it.
Yes.
Stop on your right foot. Don't forget it. Now it's time to bring it around town. Bring it around town. What time is it, Levi? Is it time?
Yes, it is time.
It is time. All right. It is time. We almost go home. We have children to feed, whether the children are ourselves, which is the case for all of you, and the case for Levi and I, because especially Levi and I. I'm not mad at you, I'm mad at myself.
I know.
And I'm not mad at myself, I'm just disappointed. Do you have pets? Yeah, Levi's my pet, and I'm his pet.
Actually, he's my executive assistant.
And I'm his executive assistant.
You're the executive to the assistant.
Is there a regional in there too?
Nope.
I help Levi out with his scheduling, he helps me out with my scheduling.
And
so
we both use...
Alta Ipsum, the app of the gods!
Have a lovely night.
Oh, call signs!